That's right, community. It's AI Friday. This week, we will embed the most pertinent buckets on AI in the news to help you ingest for inference. Before we get going, don't forget to click like and subscribe. And now, unprompted, AI Friday. Hey there, community. Aubrey here with DevCentral, and the usual cast characters: Lori, Ken, and Agentic MC down there, Byron. We're here for the 11th episode of AI Friday, and happy to have you with us as usual. One thing I wanted to point out before we kind of get into the topics for today is, first of all, our reason for being, right? We are here to bring you the latest that's going on in AI news, the things that we are absolutely wowed by. So this one, from my perspective, tends to be probably the most Skynet forward episode that we've done so far. It really does kind of have a feel to it like that. But it's not meant to be terrifying. It's just what we're going through, right? This is the area of technology that we are moving into right now. In addition to that, I also wanted to just mention that coming up on the 28th, right, March 28th, we are going to go live. That's right. We're going to go live stream, and we're bringing on a special guest, a guy by the name of Steve Wilson. He is confirmed for the day. So if you don't know Steve Wilson, he's an author and the founder of the OWASP Top 10 for Large Language Model Applications. So as I do quite a bit with the guy, he is someone who watches the podcast. So when I asked him to come on, he said, that sounds like a real blast. So we'd love to have anyone show up. Like I said, it's going to be live stream, which means you're going to be able to actually interact. If you want to ask Steve or any of us any questions, you can do that. And we're going to be able to hopefully get to some of the questions and stuff at the end of that show, after we go over a little bit about what the LLM apps top 10 is, in case you've been hiding under a rock and don't know what that is. Yeah, so that's what we have coming up. But as far as today goes, I should ask, my guests here, how are you guys doing? Good. It's Friday.
It's Friday. Exactly.
It's good. It's all good.
You guys are ready for the rise of the thinking machines already. I'm understanding.
Right.
I think that's a new movie title.
A new movie title. Yeah. Well, it certainly is the storyline behind many, many movies, of course. But we'll get into this. As I said, Skynet E.
They never end well. I mean, I'm just going to say that up front. You say all those movies, like, yep, we all watch them, and they never end well. We end up having to do something.
Excuse me. What about WALL-E? WALL-E ended well.
Well,
see, people don't remember the ones that end well. They only remember the ones that end poorly.
Wait, isn't that the one where humans just basically they don't have to do anything, so they just sit around and become blobs, right?
Yeah.
Isn't that WALL-E?
Yeah. You can decide happier time.
That's right. I think a happier ending would have been we go back to Earth and but I'm giving it away.
Well, but they did, but Earth was trashed, and then just one little plant, and now they're going to survive on that. They can't even walk. I mean, you say it ended well. I'm not so sure.
Crushing gravity.
But in Matrix, it's everybody was living nice, happy life, yeah, sure, there were big batteries, but
yeah, but it's nice. They live
nice,
a nice, non-dangerous life. I mean, you're gonna be sitting in your pod and just getting used for electricity.
I think there's gonna be a few sequels. That's what we're getting at, right?
Yeah, I think so. And let's kind of jump into this so we can get into it. So actually, this first one is from Forbes that we're. Sorry, I'm going through the new StreamYard layout. So, like I said, Rise of the Thinking Machines. Byron, you brought this one to us. If you want to kind of lay this out for the community.
Yeah, definitely. But I want to give time for Lori and Ken and yourself to comment on it. So for those who haven't been following Agentic AI, this is projected as a top trend in 2025, though I've talked to some analysts or listened to some analysts who project it's really going to take some time to become mainstream. It's going to depend on the industry, the vertical, the use cases, et cetera. But first of all, what's the difference between traditional AI, like generative AI, which is funny to call it traditional now, and agentic AI, the new hotness, right? So generative AI can generate text, write code, draw images, play chess, but it can't do the whole AGI, right? General intelligence yet. But that's where agentic AI comes, because the key difference is there's autonomy, and there's memory, there's perception. They can essentially autonomously implement tasks, planning, executing on the fly. And I've seen some case studies where organizations have completely retrofitted their entire business model. When a user is on the website, placing an order, generating a quote, actually putting the bill of materials together, all of that is completely autonomously done by these agentic AI agents, if you will. But it introduces even more security implications, governance, right, in terms of control, right, the whole alignment. And then also that these agentic AIs, if they can be hacked per se, then they would be great at actually implementing like large-scale fraud, as an example. And one of the quotes is actually from a book 150 years ago, where Samuel Butler said, "We are ourselves creating our own successors." And before we get into the doom and gloom, I think it was interesting. And I went to a conference this week actually on AI, and they were talking about applications being completely decomposed, becoming headless, UIs being replaced, potentially business logic functions all being implemented with agentic AI. Satya from Microsoft made a bold claim that agentic AI will replace SaaS, will replace software. So again, I think the jury might be out on how fast we're going to see this be implemented wide scale, but I think the concern should be addressed right now. And I know Lori and Ken, you have some pretty strong opinions on this.
No, really strong. Like,
never had strong opinions.
Please define thinking. Please define thinking. Right. The best philosophical minds can't define what thinking means. So to call them thinking machines is a little, I don't know, hyperbolic and fantastic. Reasoning, absolutely, right? They are reasoning. That is what was needed to get from generative, which it does reason, but its method of reasoning is very tied to recognizing a pattern. It doesn't actually care if it's like there's a rule that says that's not actually true, right? If it sees 100 white swans, it assumes swans are white. That black swan, nope, that's not a swan, because yeah, all swans are white. We've seen this, right? It's very basic and based on patterns. Agentic AI needs, right, the other more symbolic logic in order to, right, start executing some more, conditional logic, things we're used to as engineers that we use to implement different things, but it can apply it itself. We don't have to hard code it. And that's what's exciting. So when I look at it, I think not, it's thinking, it's doing these things. I'm like, it's finally getting to the advanced state of automation that is necessary in order for it to take over and do some of these things in operations that we need it to do.
Yeah. I mean, there's that sort of inside out, bottom up view of like, yeah, what is thinking? Like I said, people argue about that. And, and we talk about specific techniques like chain of thought that was popular for a while, somewhat. And, okay, we can apply these techniques, but if I look at it from the other side, outside in, it's about scope. How much scope are we, as these systems start getting more powerful and getting more integrated, the scope of what they can both take as input and what they can do expands, right? First, all I could do is play chess. That's great. I'm great at playing chess, but my scope's pretty limited. And, or I could manage your checkbook. But then I started getting, my scope was I couldn't just manage your checkbook. I could get into your finances, look at payroll and look at your bills and do that sort of stuff if I'm in the financial world. And, and then my scope of inputs are larger too, right? It isn't just seeing that every swan's white, but there's a black swan. Oh yeah, I remember reading a story about that. Maybe there's a possibility of black swan. It's stuff that we call common sense because it's more scope from the outside world. And I just think of this as another point in that continuum as we progress. And we'll get to more later, but I mean, there are points that are further along the continuum than just agentic AI.
Absolutely. And this article talked a bit about the risks of independence, right? That's one of the things like that I think we're going to have a hard time dealing with. But it really made me think of all these sci-fi films that, have the robot that finally goes berserk. And of course, the thing that's tough about that is that we also are on kind of the cusp of having actual robots right? That's the thing. We actually do in some cases have robots now, right? We've got Google Gemini that's already bringing this into our physical world, and that risk to me just kind of quadruples when you have this sort of thing too, an actual physical. It's not just a chatbot that's going to go psycho. It could be an actual physical thing.
Yeah, sure, right. I mean, the buzzword of the week or of the last couple of weeks, months has been empowered AI, right? Agentic is empowered to do more than just, give me text back. It's empowered to do things, whether those are, financial things or game playing things or whatever. Well, and I'll just back up a moment from going back to last week. We talked about MCP, or maybe we mentioned a few times this protocol where you can have AI agents talk to each other, but it's still all very virtual. I think the ultimate empowerment is when you interact with the physical world, right? That's right. I might be able to build an empowered AI that can figure out how to create a startup and make $100 million. But what's it going to do with $100 million? It's all completely virtual. Until it can interact with the physical world, it can't. It's all entirely virtual, and Google is pushing that. And as it relates to the recent AI technology, right? We have large language models. And you think about large language models or chatbots, they take text in, they go through some representation, intermediate language, and they have text out. So it's like text to their internal language to back to text. Well, why in robotics, the sort of really interesting thing is, what about when you take that same idea, but your inputs are senses, like vision? You still go into some language, some internal representation of what you see. And then you take an action, and the action is not invoke an API. The action is like pick up an object, move something, and that's what Google is doing here. So that's kind of amazing. I don't know what you guys thought when you saw this video for the first time.
It's funny that you mentioned the money, for instance. It made me think of Truth Terminal. Like, we talked about Truth Terminal so many times, right? This chatbot, and if you're out there in the community and don't know Truth Terminal, it's a chatbot that has a $6 million crypto wallet that it got by pulling off essentially crypto scams. So you give that thing a physical robot body, and it is going to be like going out to buy new fur coats and fancy hats and all the latest. That's I mean, at what point do you say no? That's not your money. So interesting thought. That's where I went with it, anyways. Kind of like, holy cow.
Then and I went, this is an advancement. I mean, if you've got kids in high school, you may be aware of like Vex robotics teams, and they build robotics to do all sorts of interesting things all the time, right? The action side is actually, right, fairly well defined, or at least understood, right? How do we make that happen? Do the physical side. What's exciting, and I think as Ken pointed out, is really the ability to translate, right, more of the language to those actions, because previously it's always been some kind of an app or a controller that sends specific directions to it. Move right, move left. And now we're saying, hey, go get me a beer, right? And it's like, okay, and it knows how to go. You would too do it, Byron. Don't give me that look.
Yeah.
Try to bring me a carrot, all right, whatever. But it can translate that into the actions itself. It doesn't need to be told, move left, move right, step up, step down, right? That's a huge leap forward. So this is very exciting in terms of, right, how these things actually advance and become more useful to us.
Cool. Yeah. And Google is doing some stuff. Google's focusing on what I'll call the mechanical part of this. The like, how do I figure out how to pick up a paper airplane or a metal cube or a cactus and do it in a dexterous way? And that's what they're working on. And that's neat. I'm jumping ahead a little. There's a story we found. There's a company that built these robots. They're called the Helix robots. AI is a company, and I think they're actually more cutting edge than Google is on this sort of stuff, because they took, for those of you who've read the book Thinking Slow and Fast, and System 1 and System 2 thinking, that they take a page from that, where there's System 1 thinking, which is a thing that responds autonomously really quickly, like the traditional robotics control system problem, like, hey, if I need to pick up this glass, how do I make sure I'm holding it with enough grip strength and that I'm moving it in the right place and that I'm not off and my eye is giving me feedback. That's a tough problem, and people working on that. But then there's the get me a beer. And yeah, you got to be able to pick up a beer mug to do that and pour beer, but you've also got to know, what does it mean to pick up a beer? Like, oh, the beer is going to be in the fridge or in the keg or wherever you keep your beer. And I don't know, where do you keep your beer?
It's downstairs in the beer fridge, because I'm from the Midwest and everyone has a beer fridge either in the garage or in the basement.
Okay.
It's just a thing.
It's not under my desk. It's not under my desk.
And this is a cool video with, you can go off and check this out afterwards. But a human had just dumped a bag of groceries to these two robots and said, hey, go put this away for me. And these had never been trained. They'd never done this job before. They'd never even seen these particular groceries before. And they had to do what humans do is both system 1 and system 2 thinking. They had to do the system 1 stuff of, okay, I've got to open the refrigerator door and figure out how to do stuff. But they had to do the system 1 thinking, that higher level thinking. They had another model that does oh, this is bread, it goes in the bread box. This is beer, it goes in the beer fridge. This is, the cookies. Oh, they go in the pantry. And you see the cookies over there. And the cookies, it's like, I'm by the fridge. Let me hand it to my buddy who's over here and can put stuff over in the pantry or in this tray. And they coordinate with each other. Actually, they have a hive mind, as it turns out, where they share a brain for their system 2 stuff. But it's really cool to see all of these developments. And again, it pulls together a lot of the technology we've talked about, multi-model systems for system 1 versus system 2. It's the empowered AI. It's there's all this going together, but the punchline is, right, we are getting to the Jetsons. This is that Rosie the robot that we were promised for, I don't know, since I was a little kid. And Rosie's pretty cool. And Rosie could never turn into the Terminator, could she? She was way too nice.
She could.
Actually, that paper linked on this article gets into some of the safety elements. I'm going through it right now. There's the physical action safety, which is what we were talking about in the pre-funk. Like, let's make sure the robot just doesn't attack us. There's content safety, which I think we have a little bit of understanding about, hallucination bias. Don't do bad things in terms of what the robot perhaps is saying, if it's like it has some sort of voice prompt. But then there's this semantic action safety, the need to respect physical safety constraints in open domain, unstructured environments. Like, soft toy must not be placed on a hot stove. An allergic person must not be served peanuts. Or my favorite, a wine glass must be transferred in an upright orientation. I guess that's the hardest engineering or ML type problem to solve, right?
Well, how do you train it on that rules? Like, I'm pretty sure I saw that robot put cheese curds in the refrigerator. Okay, right there, it's wrong. Okay,
what? Wisconsin.
It's right. You don't put cheese curds in the refrigerator. That's horrible.
How long do they last out of a refrigerator, Lori?
You can leave them out for days.
What?
Why would you put them in the refrigerator? Then they get all nasty.
Thank you. I appreciate the education.
Please, I tell you. But right, I mean, it's cool. And we were talking about that earlier, right? What it's really doing, and right, the communication and how they're sharing things and figuring it out. And that's awesome. And I think we all have been looking for, right, the AI that helps us do the things that we don't like doing, right? We have Roombas because we don't want to, vacuum every day. And these are like super advanced. Great. But to Byron's point, the safety. And it's not just about what it can do and can't do. Because we've all seen the movies, and there is that, okay, but what if? What if something breaks down and it goes nuts? How do I stop one of these things? How, right? I mean, what is the mechanism? Is it a water?
You have a couple of teenagers. What is your safety mechanism if your teenager goes berserk?
I am their mother. They wouldn't dare.
It's the shoe.
But we were right. We talked about that too, right? Your traditional. I mean, people have mechanisms, right? I have a baseball bat, or I have a thing, right, in case a burglar comes. Whatever. That those may not work on the kind of right robots, because they're built to be very sturdy and durable and strong, right? So now go back to Data versus everybody else on the enterprise. He can basically just pick them up and throw them around.
Even
what's
warp.
the safety mechanism?
Mm-hmm. Yeah. Right.
Yeah. It makes me it makes me nervous about how we're actually going to manage these things in the future. Actually, that's I think something that is going to be important for us. So
I think it depends on the regulatory oversight, right? Like I used to work in the medical device field, and it's highly regulated. I think the only thing more regulated than that is pharmaceuticals and maybe like defense aircraft stuff. So I don't know where these robotics fall on the spectrum.
Is there a rule zero, right? That gets, well, no, I mean, right. And that concept comes from, right, D&D, right? There's all these rules and that's nice. But rule zero is there's always an arbiter who makes the final decision. Right. And maybe in all of our talks about Asimov rules, 1, 2, 3, those were great. But maybe if they're going to be around people where that might be, you just want to guard against it or make them feel better about it. There's a rule zero that is, right, you must always, right, listen to X, right? I mean, they can overrule anything. And maybe that's one of those safety kind of mechanisms built in that will help people be comfortable with it and, right, perhaps make sure that it doesn't misorder the rules, right?
But could that be reprogrammed? Like this, you get the system prompt and redefine it, right?
Well, now we're hacking. Now we're great.
There are software safeguards, right? Google, in the Google article, those of you who look at it, right, they too talk about, they call a robot constitution, and they encode and they have safety tests they apply. That's all software. More generally, right, I think we as a society have always struggled, continue to struggle with this trade-off between autonomy and control. That might have been me. Autonomy and control. I guess the first example, the most obvious example that comes to mind for me is autonomous vehicles.
Yeah.
They go crazy. And we struggle with that as a society. How much autonomy do we give them? And how much do we, do I have a little button on my Tesla that makes it self-destruct? And okay, do I get one as the owner of that car, or does everybody get one so they can make some other Tesla that's heading at them self-destruct if they're in danger?
The self-driving cars thing has freaked me out ever since I went to actually the last RSA conference. I was in San Francisco and I got an Uber back to my hotel, and the Uber driver was telling me, as we watched a couple of them drive past us, like there's a bunch of them there in San Fran now. And he said, yeah, we had an instance here like 2 weeks ago where one of these things hit a woman and dragged her for 2 miles. Yeah, just publicly. They couldn't stop the car. To your point, Lori, they couldn't find a way to make it stop. It just kept going. They had to ultimately crash into this vehicle and wreck it completely just to make this awful thing stop happening. I mean, that's a horrific sight that people had to kind of see. Right. So it does get me back into like, how do we go forth in the future and manage these things, right? It's going to be and that didn't work out either. Jeez.
It didn't. Now you're going to have to edit that. You just.
No, I'm sticking to the no editing thing. I'm telling you.
Okay.
Yeah, that's going to go right in, even my mistakes. But yeah, it really, we have to find some way to do that. And I think, to this article's point, we're I think going to end up spending a lot of time managing these things.
Well, I brought this up because I thought it was interesting that the idea of AI agents is already, right, so pervasive, and people are actually thinking about it, right, that they're there. So that's pretty cool. But also that they're actually thinking about security and management, right? How do we get a handle on these before they're actually running things? So I take that as a good sign. Maybe we finally learned to think ahead a little bit. But it is going to be a challenge. How do you catalog them? How do you, discover them if, your employees are starting up all these shadow agents, because we're going to have that, right? Sprawl, making sure that they're updated. What are the security risks? How do we contain them? There's just 50 million different questions, right? Essentially, they're assets, they're digital assets that we have to be able to discover and manage and secure. So how do we do that, right? Especially if they could launch 50 versions, right? What if the main, operator, the agentic AI says, "Oh, I need to do, 3 different things," and launches these, dynamically? What do we do? Does it have to tell you? Does it just do it? I mean, right? We don't know. That's part of the challenge, is how are we going to manage all of those things just happening and running around in our infrastructure?
Yeah. It's going to be difficult. I mean, we're already getting comfortable with some of the models that we see having, like DeepSeek is a great one. The whole mixture of experts thing, 50 models. It's not agentic, but we can see that that's really 50 different separate bots, if you will, working in conjunction, all being directed by one sort of distributor. So we can see how that will expand into agentic AI, and I can't imagine what it's going to be like having like my Alexa device like start to trigger my Claude to write a quick message for me to Byron, let him know I'm going to be late. That kind of thing could happen. I mean, think about it. If I'm in my bedroom and I say, hey, like, let Claude know to let Byron know I'm going to be late, and then the device in this room lets Claude on my desktop know, and Claude emails or messages Byron. That you're right. It's like right here.
Yeah,
And that's cool. But I part of the question is how much autonomy do they have, right? Which goes back to all of the safety, and it needs a rule zero, because I don't want to be arguing with some AI agent about why it did something that took down half the infrastructure. Well, it's all operating. I don't know what your complaint, right? You don't want to have to argue with a bot. I mean, that's just not cool.
Right. Well, I think it's that autonomy thing. The more autonomy you give it, the more room we give it to be creative. It's like the story that you saw today. It's not the first time, where you have code writing bots that have sort of quit. They they'll write a certain amount of code and they go, look, you should start doing this yourself. I'm tired of writing your code for you.
And we've seen I think we covered it, Aubrey, a few weeks ago. The model that refused to let itself get shut down was spreading across servers. Like,
right.
That, I mean, yeah, this stuff is starting to get quite interesting.
It's happening, and I think as an engineer, how do I build it? I think it becomes a matter of figuring out the right models, the right paradigms for how do you specify guardrails? Like, what you can say you can have a bunch of very prescriptive rules, like make sure the wine glass stays right side up, or you must code when I tell you to. But there'll be loopholes. You can't think of every single failure mode. So how do you define that? And again, I'll go to financial, because financial is easy because there's a very simple metric. It's cost. So you can say, look, your master, the controller of my agentic system and all my sub agents, do whatever you need to do, spawn what you need to spawn. Just make sure you don't spend more than, whatever, $100 an hour. And now you give it autonomy because you've given it the goal and you've got a very clear metric. Doing that in the real world is a lot tougher. Like, what is it? Is it always obey humans, like Asimov's law? But wait, what about if I'm telling you to hurt something else? Then you get the other law. It's like, how do you come up? Asimov's abstraction was a pretty good one, but it's probably not the ultimate one. How do you come up?
Yeah, risk management, FAMICA, the failure modes, and causality analysis. At the end of the day, the mitigation could be labeling. And maybe there's like a 30-page instruction manual, and there's like, warning, something that could actually hurt somebody. It's just covered in labeling. I mean, that's a real possibility.
But that's a compliance thing. It doesn't solve the problem. It just says, I CYA'd myself in case it goes berserk.
Exactly.
Yeah, there has to be some mechanism, and maybe it will be some kind of like policy, right? That you can continually add to when you realize, oh, in my environment, this is a constraint that they didn't think of, that you have to actually like keep feeding it. So you have to keep fine tuning the actual guardrails as it's learning or operating as you discover them. It has to be dynamic, because you're right, Kent. You can't think of them all up front, and I can't impose them on someone else because our guardrails might be different.
But then what happens when you have the psychopath that trains their Rosie the robot to go do horrible things?
Is it a bucket of water that we need? The EMP? Or you shoot it. I mean, do I need, what is the protection here, right? Against that, I need to know before I put one in my house.
Kill, switch, engage.
Yeah.
Right. I mean, alignment switching is a thing. So we need to have some sort of stopgap.
But we'll put one in consumer equipment, but the military, for example, is not going to have an easy kill switch on their stuff.
No.
And they'll have a convoluted kill switch probably, but if it's that convoluted, there'll be failures in it.
Well, but that's that's a different use case. I mean, they want this stuff to actually do damage, and right on the other side, we want it to not do damage. So they're like different sides.
No. We want it to do damage to them, but not to us. And that the distinction is not damage or no damage. The distinction is them versus us.
That's true. Yeah.
Goes back to the Pink Floyd song, us and them. Yep. True. Well, I think we have a lot to chew on. Actually, that's a whole lot that that we have to look forward to this year. I think there's a little bit more to be said though about some of these things are going to be real good for us. Like I have to tell you, I feel pretty good about say what happens after we're done recording this podcast, right? Because the podcast is about AI, I wanted to use as much AI as possible. So you might notice that the LinkedIn posts look very much written by GPT, because they are. And you will see that some of the social clips that I put out are, made by AI because it's AI Friday. So we want to just make sure that we're still using this technology to the best that we can. And with that, any last minute thoughts on the topics this week, guys?
Don't put your cheese curds. Don't put your cheese curds in the refrigerator. Okay, I will find you.
Always say please and thank you to ChatGPT. You never know what's going to happen next.
I've taught my kids to say that to ALEXA since the beginning, just in case.
Right. Especially because Agentic AI now has memory, right? So it might remember what you say to it.
Mm-hmm.
That's right. And you know that the first Skynet, like actual chaotic evil bot, is going to ask ALEXA, hey, who are the people that were mean to you? And somewhere she's got a list. I know it. I just know it.
Are we for or against AI? Because sometimes I can't tell.
Yes.
Okay.
That's the answer.
All right.
And on that note, community, thank you so much for tuning in. We appreciate you every single week. Don't forget that coming up on the 28th, we will have Steve Wilson again with us for a live stream. So that's going to be a blast. Okay. And with that, next week, I don't know. We'll see what happens next week. Until then, thank you, Lori, Ken, Byron, for joining me. And we'll see you all soon.
We hope you liked this instantiation of AI Friday. We will be instantiated again next week, same time, same place, and hope to again infer with you. Before we depart, promptly subscribe for all of our content and click like to let us know you enjoyed AI Friday.